Alright guys, so sorry for this bit delay because this is actually my third session today. Alright, I've already taken two sessions today and that is why I got slightly late in starting this session. Alright, so how are you guys doing? Is the mains result out yet? Tell me, fast. Alright, so okay, there is some lag that I can see. Don't know why that is. Let's see. Why is there a lag? Hi Om Prakash Jadhav, how are you? How are you? Okay. Okay, that is weird. Hi Crazy March. Hello Moesha. Is the mains result out by the way? Please let me know. I still have no idea. Till the evening, till the I'm good, Crazy March. Thanks for asking. Till the evening, they hadn't declared the result. So I don't know if it is out yet or not. Is it? Oh, thank you, Crazy Maths. Alright, thank you for that. Okay, my net is fluctuating a bit, so you guys will have to bear with me for some time. I don't know, let me just check my settings once. Okay, I don't know what is wrong with this. So let me just give me 2 minutes to check my settings. The net is fluctuating a lot. Oh my god. Wow. Okay. Yes. I'm just checking my settings. Okay, the net speed seems fine. Alright, so I've restarted my software. I've restarted my internet. Let's hope things go smooth now. Alright. Alright, they seem smoother now. Alright, which is good. So then, so Moisha, is your mains result out? Let me know fast. Let me know. Hello, Sohan. How are you? Okay. Anyways, so why don't we get started? There has been a lot of delay already. So this is lecture 5 of SHM and Waves. This session that I host is meant for 2020 aspirants or also for class 12 students who are looking to revise their concepts of class 11 topics. All right. Okay. Yeah, they want to keep you in suspense, I guess. So before we get started, let me introduce myself. For those of you who don't know me, so my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi. My mains result out, I got 288. Oh wow! How is your mains result out? Uh, what did they release it separately? I don't know. Let me Google it. I have no idea. All right. So 288 is what? Mains result 2020. Let's see if it is out or not. No, it is not out yet. Out to be soon. Yeah. What are you saying? All right, crazy maths. No. The result is not out yet. Yes, it is not out yet. All right. So as I was saying, for those of you who don't know me, my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for almost past 8 years, I've been teaching physics for IIT JEE. And all my teaching so far has been in offline institutes. All right. I myself was JEE rank 447, and I've already coached many students to top ranks in IIT JEE in the offline setup. Now I hope to do the same in the online setup with the help of the Unacademy. All right. So how can you also benefit from this Unacademy subscription? Okay, buy answer sheet. All right. But is the official answer key out? Is the official answer key also out? All right. So let's see. As I said, the benefits that you get with Unacademy subscription is you have live classes, you get to interact with your educators. Okay. I didn't realize official answer key was out. So you have live leaderboards, live polls and leaderboards. You have test series and analysis, and you have live doubt clearing sessions. So all these benefits give your JEE prep a huge boost. Okay. So and on top of all these benefits, Unacademy is giving you access to all the top educators, all the best educators in India for IIT JEE. All right. So how do you get this subscription? Okay, all right. So that is a great score, crazy match. That is a crazy score. 288 out of 300. Wow. Okay. So here again. So how do you get your subscriptions? So you need to install the app. Once you have done that, go to the plus section, select your goal as IIT JEE and click on that get subscription button. When you're doing that, remember to use my code RDLive if you want to study from me and if you would like to enroll in my courses. All right. This code will also give you a 10% off. All right. But it is very difficult to tally, so who would take the headache? I prefer waiting for the result. Yes, of course. I know they have a very weird system of codes and everything. All right. And for those of you who can't afford this subscription, you can follow us on the JEE English channel. High quality content is also being provided here for free. And to stay in touch, you can join us on the Telegram app using the link shown here. All right. So if everybody is feeling ready, and so should we get started with today's topic? So this is the first class of waves. So we'll be talking about introduction, and we will be looking at understanding the key concepts of waves. All right. So okay. So what do you call a wave? How do you define a wave? So the definition is a wave is a disturbance that propagates from one point in space to another and results in transfer of energy and momentum without transport of matter. So without transport of matter. So matter should not get transferred from one point to another. If energy and momentum are transferring from one point to another without the transfer of matter, then that is what you call a wave. Hi SHM, how are you? All right. So for instance, if I threw this pen, then also I am transferring energy and momentum from here to here. But this is not a wave. Why? Because the matter is getting transferred. I am on an Unacademy subscription, sir. That's why I achieved this score. Thanks, sir, for helping me. Here for thanking you. Oh, all right. That's really good. Crazy match, and thank you so much. And I hope you do even better in your advance. All right. To define a wave in my offline class, I waved a hand like sign, but nothing came out of. Okay, no. That is not the only type of wave, by the way. That is a very specific kind of a wave, the one that you study. In general, the wave could be anything. All right, please notice that. Remember this, wave does not necessarily have to be sinusoidal. All right, that is a specific type of wave. In general, a wave is any disturbance that is traveling. Okay. So broadly, waves are classified into two categories depending on whether they need a medium or for propagation or not. So they are called electromagnetic waves, or we also call them non-mechanical waves, because recently we added gravitational waves also here. So this term is actually, you should not be using this term. This was used earlier. Recently we discovered about gravitational waves. So because gravitational waves also do not require medium to travel. All right, so that is also included in non-mechanical waves, all electromagnetic waves as well as gravitational waves. So at that time, my teacher bluntly asked, "What is a wave?" My answer, my hand movement. Okay. Yes, so no. This is not what a wave is. Okay, no. So now for propagation of mechanical waves, an elastic medium is required. All right, so the point is, I said in definition that a wave is a disturbance which is propagating. So why is the disturbance propagating? What is causing the disturbance to propagate? All right. So that is what you need to understand. That is what you need to follow. That will help you understand waves better. Why would any disturbance propagate? So as far as mechanical waves are concerned, then if you have a medium which is elastic, now the point is, in elastic medium, all the molecules have interactions, all right? And if you disturb this, then these guys will apply a restoring force, right? In an elastic medium, if one part of the medium is disturbed, then surrounding particles would apply a restoring force. It will try to bring it back to its original position. As a result, this guy will also end up applying forces on these guys from Newton's third law. So it will transfer its disturbance to these guys. Alright, and that is why the disturbance would propagate. If you do not have an elastic medium, your disturbance will not propagate. For example, when you see water, if you throw a stone in water, you will see ripples traveling. That is the disturbance which got caused by water hitting the water surface is traveling in form of ripples. But what happens if you throw the same stone in very thick mud? If you store, if you throw the stone in very thick mud, then you will not see any ripples. The disturbance does not travel. Why? Because mud is practically plastic. All right. So if a medium does not have elasticity, then it doesn't matter where you create a disturbance. What you do, that disturbance will not propagate. All right. On the other hand, the disturbances of fields will propagate on their own because fields are propagating all the time. All right. So whenever there is a source of electric, let's say electric charge, so it is creating fields which are propagating all the time. So if you disturb the position of the charge, all right, you will see that the electric fields will start fluctuating, and this fluctuation in electric fields would travel automatically. That does not even require a medium. That is what a non-mechanical wave is. All right. So next, what are the other classifications that we can see? So other classifications are progressive wave and standing wave. Depends whether the wave is carrying energy or not. If it is carrying energy, then such a wave is called progressive wave. If the energy is bound in a region and just moving to and fro within a boundary walls, then such a wave is called a standing wave. All right. Next, according to the direction of disturbance with respect to the direction of propagation, you have another kind of classification, which is transverse waves and longitudinal waves. So this is the most common type of classification that you will find in your waves. So let's talk about that slightly in detail. So what are transverse waves? So mechanical transverse waves are produced in such type of mediums which have shearing properties. So please note that they have to have a shear property, which means if the surface is disturbed, then it should try and come back. It should have elasticity in terms of its any shear force that is applied. All right. So if you have such a medium, then the disturbances in those will travel in transverse manner. So that is why such kind of waves can only travel in solids or liquid surfaces. In gases, you can never have transverse waves. All right. Liquid surface, again, because of surface tension, behaves as a stretch membrane. All right. So only liquid surface, and solids also in surface only. Inside the volume of the solid, the waves will be traveling longitudinally. Okay. So you need to remember that. Now, of course, here the direction of disturbance traveling is normal or transverse to the direction of propagation. So if a wave is traveling in this direction, then the disturbance should be happening in a direction which is perpendicular to this. That is when you will call a wave as transverse wave. All right. Next, of course, there is longitudinal waves. So longitudinal waves, the disturbance is happening along the line of propagation of the wave. If the direction of propagation of wave is this, then all the disturbance should be happening along this line. In such a case, such a wave is called a transverse wave. All right. In this type of waves, oscillatory motion of the medium particle produces regions of compression and rarefaction. So mostly this kind of wave will be seen in air. So in air, you will find, because all the molecules are moving like this, so whenever the molecules come closer, they will develop a high pressure region, which is called compression region. And whenever the molecules are moving far away from each other, they will create a rarefaction region, which is a low pressure region. All right. So these waves can travel in all kind of mediums. So they travel in solid, liquids and gases also. All right. So please remember that. Now the direction of disturbance traveling, of course, is along the direction of propagation of the wave. Okay, sir, if I throw a pencil parabolically in the direction of wave and disturbance, okay, then that is not wave. Then that is not wave because their matter started moving. Moisha, all right. The matter cannot move. Matter cannot move. Please remember this. Matter cannot move in a wave. The particles or the medium particles have to be fixed at their positions. They can vibrate about their positions. They can either vibrate like this or vibrate like this. All right. Now, usually that is how the disturbances will travel. They will either travel perpendicular to the disturbance or travel along the disturbance. It will not happen that your particle is getting disturbed like this and the disturbance is getting propagated like this. That does not happen. That does not happen. So there are only two possibilities. All right. Whenever you're disturbing a particle, either this disturbance will propagate along this line or along this line. That is why you have only two classifications. Okay. Okay. That is why you have only two classifications. As I said, why would the disturbance travel? Think about that. Think about that. So when a molecule is moving like this, so either it may end up hitting the molecules in which are neighboring it. So if it has some interaction forces with these, then it may repel or attract these. All right. So or it may maybe even collide with these. So then the disturbance would travel in this direction, or maybe the surrounding molecules will apply a restoring force on it if it gets disturbed from its mean. So then the disturbance would propagate in these directions. All right, there is no reason why it would travel to any random direction. Okay. All right, I hope that is clear. See, you have to see the logic in everything. Everything is very straightforward. All right. So tell me if you follow this, and I'll move ahead. Hi Yasser, how are you? All right. So if you followed this, should I move ahead? Now some basic definitions. This is very important. All right. So you have something called a wavelength. Wavelength is the distance traveled by a wave during the time in which one of the particle completes one vibration. So mostly when you are talking about waves, you will be talking about harmonic waves. All right. So in IIT JEE syllabus, you only talk about simple harmonic waves. So what is simple harmonic wave? If the disturbance that is causing the wave is harmonic in nature, SHM. All right. Okay, the case of restoring force is for every wave or only simple harmonic. Okay, so that will be for any kind of disturbance. All right, any kind of disturbance, any kind of disturbance. Okay, so Yasir, yeah, what exactly do you mean? I am not sure I follow. So that will be for any kind of a wave, any kind of disturbance you produce, doesn't matter. If the disturbance is simple harmonic in nature, which is SHM, see, there has to be a source of disturbance. There has to be a source of disturbance which is creating a wave, all right, which is creating a disturbance which is propagating. If the disturbance that I create is SHM, then the wave is called simple harmonic wave. All right, so in your syllabus, in your JEE syllabus, you will only study simple harmonic waves. All right, so when simple harmonic waves are traveling, then all the medium particles are performing SHM. We will study that. We will study that later when we study about the wave equation. All right. Oh, okay. Yes. I haven't gotten anything from my team. I will check with them. Oh no problem, Vineet. Good to see you here nonetheless. Okay, Yasir, I will get in touch with the team and ask them that. Yes, it is. Yes, it is. Yes. As I said, if you do not have an elastic medium, your wave will not travel. Okay. You do need an elastic medium. An elastic medium will have a restoring force. In plastic mediums, you will not see any waves. I mean, you can think of this. let's see. If you have a pool of mud, how do I say? Let's talk about quicksand. Quicksand. Okay, think of quicksand. If you throw a stone in quicksand, do you think you will see ripples? Do you think you will see ripples? So there, you can create a disturbance, but that disturbance will not propagate. That disturbance will only propagate if you have elastic properties, which means there is a restoring force. Yes, Rehan Shiraz, of course I remember you. All right, so please remember this, guys. Except for, that is why people used to believe that the space is filled with ether, which is a highly elastic medium. Why? Because light is traveling so fast. If I throw a ball on a trampoline, will it produce a wave? Yes, 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 of course. If your trampoline extends up to infinity, imagine this disturbance would travel up to infinity. All right, of course it will. Of course it will. See, when you're throwing a ball on a trampoline, see the trampoline will go down and then it will come up and it will start doing this. And you will see the entire surface of trampoline will start doing this. That is what you're seeing in water. When you throw a stone on the surface of water, what do you see? You see ripples. Where are these ripples coming from? The surface of water behaves like a stretched membrane. All right. You know that is nothing but what trampoline is. The surface of water is exactly like a stretched membrane. That is why that disturbance, that ripple is traveling all around. All right. Is that clear? Let me know if that is clear. As I said, that is why people thought that the entire space is filled with something called ether, because they knew that for any wave to propagate, there has to be a medium, an elastic medium. So they used to think, and you will realize that the wave velocity is directly proportional to elasticity. The more the higher the elasticity, the higher is the speed of the wave also. So that is why they used to believe that space is filled with a highly elastic medium, which they called ether, and they said that is why light can travel so fast. All right. So now, as I said, if the disturbance that you created was SHM, then the wave that propagates is called simple harmonic wave. All right. So in simple harmonic wave, all the medium particles start performing SHM. We will study that from the wave equation also later. All right. So what is wavelength? Wavelength is the distance traveled by the wave during the time in which any one of the medium particle completes one oscillation actually, or one vibration. All right, about its mean position. So we may also define wavelength as the distance between two nearest particles which are vibrating in the same phase, which are oscillating in the same phase. I will sleep after this. I usually sleep very late at night. All right, Papi. So this is my third class, by the way, of the day. I've already taken 2 sessions. All right. Next you have frequency. All right. Next you have frequency. So what is frequency? Frequency is the number of vibrations completed by a particle in 1 second, or it is also equal to the number of waves traveling through a point in 1 second. So okay. Let me help you picturize this. Let me help you picturize this. So as I said, whenever a simple harmonic wave is crossing a medium, you will see all the medium particles will start oscillating. All right. So imagine. So okay, I'm not proving anything first. I know you guys know how a wave looks like. So imagine a wave is traveling and it is right now here. It is right now like this. All right. Now let's imagine it shifts a bit. It shifts a bit. So what happens when it shifts? So this is what you see the wave as after some time, right? And then let's imagine it shifts further. So this is what you will see. And so on. Right, so I'm just going to make 4 diagrams only of the wave traveling. So this is what the wave would have shifted to in some time. Now let's focus on any one of the particles. Let's focus on any one of the particles. What are the individual particles doing? Okay, so let's talk about this guy. Let's talk about this guy. So okay, so imagine imagine a particle which is here. So imagine a particle which was here. So when the wave shifts to this, what is happening to this particle? This particle has moved here. When the wave shifts further, then this particle has come here. When the wave shifts further, this particle has come here. So you realize this particle is oscillating as the wave is shifting, and the time in which this will complete one oscillation, you would have seen the entire one wave would have passed this point. All right, so that is why when you're talking about frequency, you could have defined it in both ways. It'll be the same. The time taken for one particle to complete one oscillation, or time taken for one complete wave to pass through a point. All right. Now, similarly, what is the time period? Time period again would be the time taken by the wave to travel a distance equal to one wavelength, or the time taken by any medium particle to complete one oscillation. All right. So obviously these two would be related to each other as T would be equal to 1 over nu. I mean, just like SHM. So this is just like SHM. All right. Okay. Next, you have angular frequency. Again, this is the same thing. I said if the input disturbance was SHM, then all the particles start performing SHM with the same omega. By the way. All right. This is if you are assuming no loss of energy. By the way. All right. So in your syllabus, in your JEE syllabus, you focus only on non-dissipative simple harmonic waves. Okay. So the syllabus for you is very specific, very limited. All right. So that is why you will realize that all the medium particles, if I start a disturbance here, suppose I start a disturbance here, I give this guy an SHM with amplitude A, angular frequency omega. What will happen is after some time, every particle would start performing SHM. We will see that from the wave equation also. Don't worry. But you will see that every particle, if I started moving this, every particle will eventually start oscillating with the same amplitude A and same omega. All right. So that is the omega of this SHM is what you call angular frequency. All right. Again, this is also called the rate of change of phase because the entire wave's phase is changing. All right. So when it is passing through a point. So as the phase of oscillation of this particle is changing, so is the phase of the wave that is passing through this point. So you could have called angular frequency as the rate of change of phase of a wave. All right. Similarly, you have amplitude. Amplitude is nothing but the maximum displacement of the medium particles from their equilibrium positions. All right. So these are basic definitions. This would be very similar to your SHM. Why? Because we are focusing only on simple harmonic waves. That is not necessary, however. All right. Then, of course, you have phase. So phase is a quantity which contains all information related to the vibration again. So in what phase of vibration is it? So it is this quantity, which is the argument of sine, just like SHM. The argument of sine or cos is called the phase. Then you have a new thing here, which is called wave number. So what is wave number? Okay. What do you think is wave number? It is defined as this. So what happens is, think about it. In lambda distance, the phase of a wave changes by 2 pi. All right. So in 1 meter, by how much will the phase change? In 1 meter, the phase will change by 2 pi over lambda. So wave number is nothing but the change in phase of the wave. Change in phase of the wave in 1 meter. If you travel 1 meter along the direction of propagation of wave, then the phase changes by 1 meter. Okay, Madhvi, thank you. All right, thank you for your opinion. I am glad. Okay. Anyhow, so let's focus on the teaching. All right. Just a second. So similarly, you have wave number. Wave number is what it is defined over as 1 over lambda. So lambda was the length of one wave. Lambda equals length of one wave. All right. So if I ask you, okay, okay, so okay, I will get this ID blocked. Okay, so let me just give me 2 minutes. Just give me 2 minutes. All right. Just a sec. Hello. All right. All right. So don't worry, don't worry. I have reported that ID and it will be blocked. Okay. Anyhow. So getting back to the discussion. So as I was saying, lambda is the length of one wave. So how many waves will be in 1 meter? How many waves will be in 1 meter? That will be 1 over lambda. That is what your wave number represents. All right. It is the number of waves in 1 meter length. All right. Now we will talk about the wave equation. All right. So I left this sheet blank because I wanted to write everything here. Okay. Let's see. Why did my display go off? Okay. So it is back. All right. Yeah. I mean, trust me, Vineet, I'm too old to even bother about all this. Yeah, I know. I really don't I really don't bother about people's opinions because how many people are actually qualified enough to judge others. All right. So I don't know. So people may feel that they are qualified enough to judge everyone. I don't like judging anyone that because of that only because I think who am I to judge anyone? But in any case, if somebody likes to judge someone, it's up to them. I really don't care. All right. So let's talk about the wave equation then. Let's talk about the wave equation. So first of all, you need to understand one thing. Okay, I'm not going to show you the proof of this because this is a revision class. But the general differential equation of a wave. Let me tell you that general differential equation of a wave is del 2y by del x2 equals into c square equals minus of del 2y by del t2. So that is the general differential equation of a wave. All right. So please remember this, that this is the general differential equation of a wave. Okay. Now, which means that any equation which is satisfying this differential equation would be called a wave with some additional conditions. By the way, this is a necessary condition but not the sufficient condition, unlike your SHM, where one condition was both sufficient and necessary. So this is, yeah, what's the point also, Vineet? I mean what's the point? So yeah, what's the point of calling somebody something? What difference will it make? All right. All right. So anyhow, as I said, this is the general equation of a wave. So any equation satisfying this differential equation with certain conditions would represent a wave equation. So let's write that any equation satisfying this differential equation will represent a wave if, so there are two conditions. There are two conditions to this. Okay. Yes, I agree, Moesha. Exactly. I agree. Alright, so any equation that satisfies this differential equation will represent a wave if, one, it has to be a bounded function. If the function is a bounded function. So please remember this. So not every equation which will satisfy this will represent a wave. It has to be a bounded function. Why? Because mathematically you can have unbounded functions, but in reality, when a disturbance is propagating, then the y or the displacement of any medium particle can only be finite. It cannot be infinite. So that is a condition which you have from real life. All right. So this is a mathematical equation. You put that condition on this mathematical equation, then turns out you will have a wave equation. All right. So remember two conditions for anything to be called a wave. One, it has to satisfy this differential equation. Second, it has to be a bounded function. All right. So if both these conditions are satisfied, then that equation can be called a wave equation. Now, a lot of family of equations would satisfy this wave equation. One such family is, so example of this is f y equals f of ax plus minus bt. You will realize that this will satisfy this wave equation. No. What I am saying is the y has to be bounded. The y has to be bounded, not the medium. See, if the trampoline extends up to infinity, it doesn't, it's okay. The displacement of the portions cannot be infinite. The displacement of the portions cannot be infinite. That is what I'm saying. See, in space, imagine you can theoretically have a string which is infinitely long, but when you're displacing that string, the displacement of the medium points cannot be infinite. All right, I hope you understand what I'm saying. Here y represents the displacement, so bounded in y, the function should be bounded in y. The medium particles cannot get displaced by infinite amounts from their mean positions. All right, a medium extending up to infinity is different thing. Now, medium particles getting displaced from their mean positions by infinite amounts is another. All right, I hope you understand the difference. Is the difference clear of what I'm saying? Okay. What is y? What is y? What is y? Y is the displacement of medium particles. In space also, first of all, there is no medium. Even if you're talking about EM waves, the EM waves will have a finite amplitude. What I'm trying to say is that no wave can have an infinite amplitude. Okay. See, if there is a mean position, you cannot get displaced from your mean position by infinite amount. But if you have a medium, if the medium is getting infinitely displaced, then the medium is traveling, right? The medium is traveling, medium will never come back. Then that is not a wave. Try and understand what is wave by definition. Wave by definition is transfer of energy and momentum without transfer of material medium. So even if medium gets displaced from its mean position, it has to come back. It has to come back, right? If you make the displacement as infinite, that means it is never coming back, which means the medium got transported. All right. If medium got transported, you won't call that a wave. You won't call that a wave. Okay. I hope it is clear now. All right. So I'm sure you ended up confusing everybody else. All right. Okay. So this, you will realize this will follow this. So such a equation represents a wave. It is a family of progressive waves, by the way. This is the general equation of progressive waves. General equation of progressive waves or traveling waves. So that is what this is. So as long as until it is a bounded function. So this function has to be a bounded function. Okay. So this, if this is a bounded function, then this family of equations which this expression will represent a okay. So if this is okay. I think here this should not be there. Yeah, this would not be here. Sorry, I think I added the minus sign by mistake. आपको डाउट कहां पूछूं? ओके, कहां पूछ सकते हो? Maybe talk to Moesha after the session. Moesha will tell you. All right. So this is the general equation for progressive waves. Now see what is happening. What is happening? There must be a source. There must be a source of disturbance. All right. So let us say the source of disturbance. Let the source of disturbance be at x equals 0. So wherever the source of disturbance would be, I will call that x0. All right. I mean coordinates are for me to choose, right? So I will call that 0. Then what I get is that at that point, therefore, at that point, what is the motion of the object? It is f of plus minus bt, right? All right. So if I imagine that the source of disturbance is at x equals 0, now if I try to notice the motion of the particle at x equals 0, I have a function like this. So this is the function which is deciding how that particle is moving, which is being disturbed by the source. All right. So this function is defined by the source. So this function is defined by the source. All right, please remember this. You are the one who is putting the disturbance. You are the one who are deciding how the particle at x equals 0 should move. So whatever function you give it, whatever periodic function you make it move like, so it will start moving like that, and that is the function that will propagate also. From here, what you will see is, if you give this kind of function at every other point, for at any x equals, let's say, x naught, you will see that the motion would be f of a x naught plus minus bt. So you will realize that x naught is fixed. So the time variation of this point would be just like the time variation of motion of the source. So whatever, however disturbance you are creating, the same kind of disturbance will get propagated. And the only thing is that the graph would be slightly shifted. This is shifting of axis. If you add a constant, all right, I hope you realize that mathematically what you're doing is you're shifting the axis. Okay. I hope you know that if I draw y equals x and if I write y equals x minus 2, what am I doing? What am I doing? I'm shifting the graph. All right. So when you add this, what is happening is the disturbance is getting slightly shifted in its phase. It is reaching the particle late. So what happened sometime ago will happen to this particle sometime later. All right. So what all can you find from this equation? So let's talk about this equation first. All right. So if y equals f of ax plus minus bt. Now what all can I find from here? What all can I find from here? So there would be three things that I can tell you from this equation. There are three things which we can find from this equation. One, we can find the amplitude. We can find the amplitude. How do you find the amplitude? So I told you that this has to be a bounded function. So bounded function means y will have its limits. Alright, so the limit of y would tell you the maximum displacement which the particle can have. So it will be the limits of y. Limits of y with respect to mean position. So you find the limits of y and whatever is the maximum that y can go from its mean, that will be the amplitude. So that is one thing that you can find from this equation. Second, what you will realize is that if something, so let's say at x equals 0, t equals 0, what is the position of particle which is x at 0? Okay, so it is f of 0. So imagine a particle which is at x equals 0 and at t equals 0. At t equals 0, its y displacement is f of 0. Now what I want to know is, if at x equals 0, this is somewhere here which is y of f of 0, after some time t, when this disturbance reaches some place x1, then at this point this guy should also have this displacement. I hope you agree what I'm trying to say. Imagine at x equals 0, t equals 0. I look at the particle at x equals 0, at t equals 0. So I find it somewhere at y equals f of 0. Now after time t, I say that this disturbance has traveled to a point which is x at x equals x1. Now what do I mean when I say this disturbance has traveled? That means at this time, if the disturbance has traveled, so let me just write it here. If the disturbance travels x1 in t time, so what does that imply? That implies, this means that at t equals t, okay, so let's call it t1, t equals t1, x equals x1 should have the same displacement, should have y equals f of 0. Agreed? I hope that is making sense to you what I'm trying to say. I'm trying to say, if you created some disturbance at x equals 0, at t equals 0, and if that disturbance travels to by a distance x1 in time t1, then that implies that if I look at point which is at x equals x1, and if I look at it at time t equals t1, then it should have the same displacement that the previously my source guy had. All right. So now I can say that, therefore, ax1 plus minus bt1 should be equal to 0. From here what I get is x1 over t1 equals minus plus b by a. Alright. Now, what is this? This is nothing but wave velocity. This is called wave speed. All right, this is the distance that the wave is traveling per unit time. So if you had this equation, if you had this general equation y equals ax plus minus bt, from that you could have told the wave speed. The wave speed would have been minus plus b over a. Now this minus plus sign is telling you about the direction of propagation. All right, please note. Minus plus tells about the direction of propagation. In which direction is the disturbance traveling? So obviously minus means disturbance is traveling along the negative x-axis, otherwise it is traveling along the positive x-axis. So this means disturbance travels along minus x-axis and vice versa. All right. Please let me know if you followed everything that I have said here. In the equation, in the wave equation, there was plus minus, but actually, should we take in a general form? Okay, what actually should we take in a general form? See, plus minus would depend. Plus minus would depend on the direction. If the wave is traveling in plus x direction, you take negative. If the wave is traveling in negative x direction, then you take positive. Okay. As I said, these are two possibilities. There are two possibilities. Either your wave could be traveling in plus x direction or your wave could be traveling in minus x direction. All right. Do you understand that? See, plus and minus both will satisfy this differential equation. Plus and minus both will satisfy this differential equation. Let's check. Let's check. So y is f of ax plus minus bt. You will realize what will be del y by del x2, y del x. So that will be a times f dash ax plus minus bt. Similarly, del 2y by del x2, that will be a square f double dash ax plus minus bt. Similarly, your del 2y over del t2 would be again b square. Doesn't matter whether you took the plus sign or the negative sign. Both times when you are taking the derivative two times, you will have plus minus b whole square f double dash ax plus minus bt. Alright, so you will realize from here that b over a whole square del 2y by del x2 equals del 2y by del t2. Alright, that is why this is called the wave speed. C, it is represented with C. Sir, we are given the equation in exam. Will the direction would also be given? Yes, of course. Of course it will be given. Otherwise, how do you choose whether it is plus or minus? Hi, Puneet. So that is why you see this is called C square. This is called C square, where C is wave speed or wave velocity sometimes. Speed of the wave. So you can figure out from here also. In general, this is always the wave speed, whether the equation is of this form or not. Even if the equation is of another form, then also this term is always wave speed, turns out. Okay. Again, I'm not going to show you all the proofs, alright, because this is supposed to be a revision class, but I'm still going through all this so that you are clear about your concepts. Okay. So in this, C is always the wave speed, by the way, which in this case becomes minus plus b by a, and the sign is telling you whether it is traveling in the positive x or negative x. So just remember this, that from this equation you will be able to find three things. Alright, from this equation you will be able to find three things: amplitude, wave speed, and the direction of propagation. Direction. So three things you should be able to find. So why don't we? Okay, so I left another sheet. So in another sheet, yes. Now I remember what I wanted to tell you. In another sheet, what I'm saying is, so I told you this is the disturbance that you are producing, right? I told you this. So what happens if you decide that this disturbance is SHM? If you decide this disturbance is SHM. So I discussed that y equals f of plus minus bt is decided by source. Is decided by source. Now, if source decides that the kind of disturbance that I will give is SHM, then for SHM, what will be this? For SHM, this obviously function would become a sine omega t. All right, plus minus again. For SHM, this would take up this form. Okay, I can even have some phi plus some phi naught. All right. Now I know if this is this, then my wave equation. Therefore, wave equation. What would the wave equation look like? Wave equation would look like y equals a of. I have to add ax also here. I just have to add ax plus minus bt instead of bt everywhere. So my this equation becomes some kx plus minus omega t plus phi naught. This is the general equation for a simple harmonic wave, simple harmonic progressive wave. All right. So this is the kind of wave that is in your syllabus. This is the kind of wave that you discuss in detail, that you study in detail, but you need to know everything behind this. That this is only a very specific case when you decide that the kind of disturbance that you will propagate is SHM. All right, so you need to know this. So remember, this is the general equation of a simple harmonic progressive wave. General equation of a simple harmonic progressive wave. So very specific kind of a wave. All right. So this is what you will focus in your syllabus. All right. Your syllabus is limited to this, and it is a matter of tradition that instead of A, I am writing K. All right. That is just a matter of tradition that I use instead of A and B, I am using K and omega. All right. That is to find the similarity with SHM. All right. Wouldn't have mattered if I had used different symbols also. I could have written sine A, capital A sine small ax plus minus bt also. That would have worked equally fine. So now if you have a progressive wave, now what you can see is that if I give my input, if the disturbance that I produce is an SHM of amplitude A and angular frequency omega, at every point in time, when I keep on changing the value of x, I will find every particle will be performing SHM with A and omega only and in shifted phase. All right. So if I move from one particle to another, every particle is performing SHM exactly with the same amplitude, exactly with the same angular frequency or the same time period, but the phase of every next particle would be different. So for such a wave, the phases of all the particles are different. So what can you notice from this equation? So let's just write those conclusions. For such a wave, I can see 1. All particles perform SHM with the same A and omega, with the same amplitude and omega. So I can go anywhere in the medium. If I look at the motion of the medium particle, I will find it performing SHM with the amplitude that I produced, I created. If I cause this wave motion, then whatever amplitude. So amplitude is always defined by the source. Please remember, amplitude of a wave is always defined by a source. All right, and so is omega. All right, the angular frequency, both of them are always defined by the source. And B, all adjacent particles. So when you're moving from one particle to the next, you will see the phase is changing. All right, all adjacent particles oscillate in different phases. And that phase is slowly changing. All right, now please note one thing. A and omega are being decided by source, are always decided by the source. So you cannot guess them for any wave equation. They will either have to be given or some conditions would have to be given. All right. A and omega are always decided by the source. The source will decide what the angular frequency of SHM should be. The source will decide what the amplitude of these SHMs should be. All right. So whoever is producing the disturbance will decide what the amplitude of the entire wave or the time period or the frequency of the entire wave will be. All right. It is always, both these things are always defined by source. All right. Now, in our case, we also consider that all these waves are in 1D and they are in a non-dissipative medium. So there is no loss of energy. By the way, there are these assumptions. There are assumptions that your medium is non-dissipative, which means the amplitude does not change. In reality, what happens? In reality, what will happen is so as the wave will travel, you will realize that the amplitude will go on decreasing. Why? Because there would be dissipation. And in case of ripples also see, sir, ideally at any point the amplitude and frequency will remain same. Yes, for a 1D wave, for a 1D wave. So this is a 1D wave, by the way, one dimensional wave. All right. I mean, suppose what is happening if you throw a stone in the water. Now the ripples are spreading, so the energy is spreading in the area in which it is moving. So there the amplitude would go down because even if there is no dissipation of energy, with distance you will see that the amplitude is going down. Something like light intensity. If you have a bulb here, the light intensity will fall off if you move away. So if the light intensity is falling off, so is the amplitude of E variation. All right, or sound. Consider for that sound also. If you have a source of sound which is kept here, which it might be producing an amplitude, but if it is traveling in 3 dimensions, the energy or the intensity, we will talk about that, the intensity would decrease. So in these waves, in 2D and 3D waves, the amplitudes would decrease, even if there is no loss of energy. All right. In 1D waves, the amplitude will not decrease. Okay. I hope you got that. Okay. This is a wave equation which is traveling in 1D. It is only traveling in X. Please notice, this is a 1D wave. Only traveling in X. All right. Yes, not for a 2D wave. No. Then things will start changing. Don't worry, that is not in your syllabus. That is not in your syllabus. Okay, so it can be anything. It can be anything. Doesn't really matter. Doesn't really matter. You can write any form. Doesn't really matter. Both these equations would show you, would represent traveling wave. Doesn't really matter. Like in SHM, I can always change the value of phi naught. You realize that? I can always change the value of phi naught accordingly. If you wanted that kind of equation, I can keep my phi naught as pi. It's just the same. Okay, Vanchika? It's the same equation. You will put other value of phi naught. It gets adjusted there. Okay. Alright, so why don't we have a practice problem? So enough of discussion today, a lot of discussion today. So why don't we practice a problem? Alright, so which of the following functions represents a traveling wave? Okay, so there might be more than one correct, by the way. Represent, because it says represent. Which of the following functions represent a traveling wave? So why don't you guys try this? Okay, alright, so let's see. Okay, okay. Only C. Only C. Okay, how about others? So okay, good, good. Yes, yes. So I had said earlier that any wave which is of this form, and if it is bounded, it will represent a wave equation. All right, any function which is of the form of ax plus minus bt and is also bounded. So yes, C is the only bounded function. C is the only bounded function because these are unbounded functions. So that is why they do not represent waves. All right. Okay. So that is correct. Absolutely. Okay. So that was simple. So why don't we move ahead and practice one more problem? So if a wave is represented by equation, yes, yes, Moisha. All right. If a wave is represented by the equation y equals a, so this is e to the power of minus x over a plus t over t. Find the amplitude, velocity, and the direction in which the wave is propagating. All right, you have to find all that. What would be the amplitude, velocity, and the direction in which the wave propagates? All right, so this is a e to the power of minus x over a plus t over t. So this is your wave function. This is your wave function. You have to find the amplitude of this wave. Yes, amplitude would be a, obviously. That is the maximum possible value of y. So yes, that is correct. And how about the speed? How about the speed? Okay. Yes. And the direction? So absolutely. By capital T. Capital T. Capital T. Yes, so those are the correct answers. So as I said, you should be able to tell me about all these from this wave equation. Alright, so those are the correct answers. Amplitude would be A. The wave speed would be A by capital T, by the way, not small t. Alright, and obviously you will have a negative sign here denoting moving in minus x. Moving in negative x. Alright, so yes, that is how you find these things about from these wave equations. Yes, yes, alright, great. So that means you should be comfortable with these kind of questions, alright? Because JEE Advanced has asked these kind of questions, alright? Mains people do not ask anything outside simple harmonic waves, but advanced can ask you non-harmonic waves also. So these are non-simple harmonic waves, by the way. Some of them might not be even harmonic. Alright. So next, why don't we practice a problem from the general wave equation of a simple harmonic wave? So here you've been told a wave traveling along a string is described by the equation y equals 0.005 and times sine of 80x minus 3t, in which all numerical constants are in SI units. Calculate the amplitude, the wavelength, the time period, the frequency, and the displacement of the particle at x equals 30 centimeters at t equals 20. Okay, so calculate that. Now, one more thing. When you're talking about waves traveling along a string, okay, I'm not showing you the derivation, but there is an assumption. Assumption is that when the wave is getting twisted like this, so this theta, the slope of the wave should always be very, very small. All right. So please remember that. So let me just write it down. So for waves in a string, we assume the slope. So if you see the derivation, you will realize that there is an assumption there in the derivation. In the derivation, there is an assumption that the slope of the string is always very small. Always very small. That is why whenever you see questions, you will notice that the amplitude is kept very, very small. That is why you always keep amplitude very, very small. To ensure this, the amplitude of these waves is always kept very, very small. Is always kept very, very small. Again, I'm not showing you the derivation, so that is why you will have to just remember this. Okay. So which you will notice also that your amplitude generally would be in mm's. Okay. In general, you will notice that all your amplitudes would be in millimeters. If you had an amplitude in meters, trust me, that equation is wrong, because that will not follow the assumption that we took, and that is why then you can't use this equation to represent that kind of wave. All right. Okay. So all right, you guys have given the answer. So obviously this is correct. The wavelength is 2 pi over 80. Yes. So this is k. K is 2 pi over lambda. So obviously, all right. Frequency, this is omega. So it would be frequency would be omega over 2 pi. So 3 over 2 pi, yes, absolutely. Time period obviously would be 2 pi over 3, yes, absolutely. Frequency obviously, okay, so you got everything. So yeah, I mean this is simple only. This is just for you to get warmed up and get used to the wave equation. Just to remind you, jog your memory about how you can draw all the information from the wave equation directly. All right, so you guys seem pretty good at this, so I don't need to really remind you much of this. All right. So of course you put the values is straightforward. This is a straightforward problem. Just to jog your memory that this is how we would calculate things from the wave equation. Yes, of course. All right. All right. So can we move on to the next question? Yes, I'm sure. So that is not an issue at all. Okay. All right. Okay. So will there not be an X term? So this is what 80 into 0.3. So okay, 24. So there will be a 24 also. No, there will be a 24 also. Vanchika. 24 minus. Okay. You put all the values or what? Okay, you 24 minus 60. Okay. Fine. Yes. All right. So this is simple enough. This is simple enough. So again, let's have another simple problem. A progressive wave of frequency 500 hertz is traveling with a velocity of 360 meter per second. How far apart are 2 points which are 60 degrees out of phase? All right, or pi by 3 out of phase. So give me an answer for this. All right, quickly, hurry up. Can I have the answers quick? 30 centimeter. Okay, are you sure? No, I don't think so. No. Just check your calculations once. Just check your calculations once. I think it should be 12 centimeter. Okay, just check your calculation once. Vanshika. Otherwise, I'll see. Let's wait for Moisha's answer also. Let's wait for Moisha's answer as well. Yes, that's what I said. Yes, 12 is correct. 12 is correct. All right, great. Okay. All right. Yes. Yeah, okay. Is it 6,000? Yeah. Yep. 6,000 by 500 is correct. Absolutely. Okay, great. So, Moisha, what happened to you? Do I have an answer from you? Moisha, are you getting an answer or should I go ahead and solve this? All right. Good to see you, Rohit, after a long time. Yes, 12 centimeter is the correct answer. Good. Well done. So you guys should remember lambda into nu equals c. So from here you can get lambda equals 360 over 500. Alright. And you know in lambda the phase changes by 2 pi. So phase change of pi by 3 would happen in lambda by 6 distance. So lambda by 6 would be your answer. Delta x should be equal to lambda over 6, which is 1 by 6 into 360 over 500. So yeah, so that'll be this. Okay, 60 over 500 meters, or which is also equal to 12 centimeter. All right, good. So all you guys are getting a hang of this. So here is another problem. The equation of a wave is given as follows. Hi Roshan Kumar, how are you? The equation of a wave is given as follows. Y equals 0.05 sine pi by 2 times 10x minus 40t minus pi by 4. Find out the wavelength, frequency and wave velocity and the particle velocity and the particle acceleration at x equals 0.5 at t equals 0.05 seconds. Yes, Roshan Kumar, you're very late. You're almost late by 1.5 hours. It's okay. You can watch the recorded version of this later. Don't worry. You missed all the discussion, all the fun discussion that we had. It's all right. All right. See, you should try joining the class in time because otherwise you are losing out. See, if when I was having the discussion live, if you did not follow it, you could have asked me here in the chat, Sir, I'm not following this, please repeat this, or I didn't follow this, so please explain that. Now, when you watch the recorded lecture, you won't get that chance. All right, so no need to say sorry to me. It's you. It's just you will be losing out. Yes, yes, yes. Okay, Vineet. So where have you been, Vineet? I thought you had gone off to sleep. Oh, okay, 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 Roshan. All right, no problem. Okay. So what is the equation of a wave? Equation of a wave is given like this. So lambda, okay, lambda is 40. So okay, yeah, that seems about correct. 40. Let's assume everything is in SI. Okay, so that would be very long. The wavelength 40 meters. Okay, okay. Assuming everything is in SI, the wavelength would be 40. Okay, zero point 0.4. Frequency 10. Okay, zero point 0.4. Yeah, let's see. Yeah, it would be 0.4. 0.4 actually. You are right. Will not be 40. That's what I was thinking. Okay, Vineet. Okay. So frequency is 10 hertz, which is fine. But yeah, the wavelength would be zero point 0.4, not 40 meters. 40 meters is an awfully long wavelength. And of course, if you have lambda and this, you multiply them. So yes, wave velocity would be 4 meter per second. So you realize, compared to all other dimensions, this is kept very small. The amplitude will always be kept very small. Otherwise, our assumption will get violated. Okay, so B, particle velocity. Okay, 140 meter per second square. Okay, how about the particle velocity? So this is simple. Just substitute the values of x and find the expression for SHM of that particle, and you can easily get the particle velocity and the acceleration. Okay, so that should be very simple. Okay. 140 meter per second square. Wow, that also seems a little huge. Let's see. So obviously let's just write it in the more traditional form. So you have y equals 0.05 times sine of, let's take that pi by 2 inside. So I have, okay, so 10 pi by 2 x minus pi square by 8. Okay, no. Minus 20 pi t by t minus pi by 4. So this is my expression. So this is my k, this is my omega. So k equals 5 pi, which is also equal to 2 pi over lambda. So obviously your lambda would come out to be 0.4 meters. Similarly, your omega is this, so your frequency nu would be 2 pi over omega over 2 pi. So which is 10 hertz. And of course, if you have your lambda and nu, you know c is nu lambda. So that would be 4 meter per second. And then of course, for the second part, it's very easy. All you need to do is substitute the value of x as 0.5. So if you substitute the value of x as 0.5, let's see what you get. So at x equals 0.5, what is the equation of SHM of my particle? That would be 0.05 sine of, that would become, okay, so 5 by 2. So 2.5 pi minus 20 pi t minus pi by 4. Okay, so that is the equation that I'm getting. All I need to do is differentiate this twice to find the acceleration, differentiate this once to find the velocity. All right. Okay, so you guys are giving me different answers. So let's check. So what would be dy by dt? Dy by dt obviously would be 0.05 into 20 pi. Okay, so again with a minus, so 20 pi, and it would be cos of at t equals 0.05. So 0.05. So let's just see. Cos of 2.5 pi minus 20 pi into 0.05. So that is 5 over 100. All right, minus pi by 4. All right, so that is, this gets cancelled. So that is, so dy by dt or Vp, velocity of the particle is, so this would be 20. Okay. So again, this would be 1 pi times cos of, so that would be 5 by 2 pi, 5 by 2 minus 5 by 4. So I don't know what you guys are getting your velocities at, but I am getting something different. Cos of, this will be 5 by 4 pi. Okay, cos of 5 by 4 pi would be minus of, okay, so plus minus doesn't matter, but it is cos of pi by 4 essentially. So 1 by root 2. So I am getting my speed as pi by root 2. Okay, so how are you guys getting 4.5? What did you guys do? What did you guys do? The particle speed cannot be that high, obviously. The particle speed cannot be that high. I think this is fine. Okay. Just check your calculations, guys. Just check your calculations once, see what you did wrong and where you did it wrong. Because this is what you should be getting your answers as. Alright. Okay, so acceleration again, I just need to differentiate this again. So, okay. This would be, so d2y by dt2 would be again, so the angle would remain the same. So, yeah, only omega gets multiplied here. So that would be pi into 20 pi. So that will be roughly around 200. And then cos of sine of 45 you will have. Instead of cos, you will have sine of 45. So again, you will get 20 pi over root 2. So that is root 2 into 100. Alright, so 141. 141 would be the acceleration. Yes. Alright, so now you guys are giving the right answers. What were you doing before? What were you doing before? That's what I said, Moisha. 140 meter per second sounds like a huge speed. So whenever you are giving your answers, please cross-check them logically also. Alright, great. So please take care of your calculations, people. Alright, of course, let's write some units. This is meter per second, this is meter per second square. Alright. Okay. Yes, you need to be careful about that. Okay, so that is it for today. That is where I would like to wrap up today's session, so you guys get some more practice, because looks like you need it. Alright. Okay. Alright. Did you remember me or do you remember me? Yes, Lyrical, I do remember you. Alright. Anyhow, so this is where I would like to wrap up today's discussion. I hope I helped you jog your memory about waves and got you some practice. From what I see, you guys need some more practice. So catch hold of some more basic problems only. Get some practice, and tomorrow we will take this discussion forward. And tomorrow we will start our discussion about superposition of waves. All right. So we will talk about interference and everything. All right. No problem, lyrical. All right. Now, before I leave you, let me remind you that you should be getting your Unacademy subscriptions if you haven't gotten them already. So these are free sessions which I'm conducting on YouTube. Besides that, I also take courses on the Unacademy app. So if you would want to join a course by me, then you can get your subscription and join me there. All right. So how do you get this subscription? So you go to the plus section in your app. You go to IIT JEE as your goal, and you click on get subscription. And when getting a subscription, these are the cost of 1 year and 2 year courses and other courses. You can use this code RD Live. This is my code. So if you like my lectures, if you want me to coach you for your IIT JEE, then you can use this code or dedicate your subscription to me. All right. So that is it. If you like today's video, press the like button. Share it with as many people as you can. As I said, those who can't afford this subscription can learn from this series of free videos which Unacademy is providing to you. Quality content completely for free. All right. Thank you, Roshan. All right. So make sure more and more students are benefiting out of this. So share it with all your friends. All right. No, I am using Apple Pencil. Apple Pencil. I will be very horrible if I started writing with mouse. My handwriting is not good. Don't forget to press the bell icon, and the PDF of all the slides used in today's lecture would be available for download in, let's say, 3 days time. Okay, so you'll have to give me that time, and I'll upload the PDFs. Now, for those of you who are following us on the JEE English channel, you can connect with us on the Telegram app using the link shown above. All right, so if you connect with us there, you will get the notifications of all the lectures and sessions that are being conducted here on the JEE English channel. All right. So that is it. That is my time today. I will see you guys tomorrow at the same time, 9:15. All right. So there we would carry forward this discussion. We will talk about interference. We will talk about superposition of waves, and we will talk about the phenomena resulting from superposition of two traveling waves. All right. So good night to you all, and till then, you guys keep practicing, keep studying, and not to forget. Whenever you're getting your next Unacademy subscriptions, use this code RD Live and enjoy a 10% off. All right. So that is it. Take care.